Hello, my name is Jack Northcutt with team number 10, project 19, the solar system designer. I'm going to get right into the user perspective of the project. Currently, I have a WebGL build with the project, and I'm hosting it on GitHub. Gave it a domain name called solarsystemdesigner.tk. You can visit this site anytime to view our project. It will be updated after every sprint. This was made by the request of the we did this because of the request of the sponsor, so he could show his colleagues our project's progress. And eventually this project is going to be hosted on a web server. So currently right now you can see the view. We have some planets orbiting around a star. And currently these planets are not on using physics. They're using a rotation script around the planet's axis. We wanted to have the whole back end and front end kind of set up for this part before we integrated the physics into it, because we wanted to make sure that we didn't want to integrate physics too early and have it cause other problems with kind of the basic setup, since we were all new to Unity itself. But yeah, so the user can see this view, and they can also use the camera controls to actually look around. You can see planets out in the distance, larger planets, and you can also zoom in and out of the system. And we have a menu option. The user can select any of these, but if you select add object, we had this as a functionality to add an object in. Which it did, but it didn't, since we don't have physics implemented into it yet. It just kind of sat there, so we took that out for now. And we got a debug console up, so when we want to later in the future test and debug our system, we can type in command lines and view our status and logs of the system. And that's currently what the user can do with our program so far, which is where we want to be at the moment, with accordance of our design plan. And if we open up Unity here, this is the same program that's actually playing on the website now. You can see here to the left at the top, this is our scene, and we have all our camera controls, our planets and textures and everything added in here, along with the console and menu windows. Down below is our the actual code itself. In the editor section, we own the tests, and then we added in the skyboxes, but I think the skyboxes were actually open source sky images, and we formed them into a box. And same with some of the textures and stuff. Obviously, you can see we didn't create these, but Liz did design the planets in. And if you look down here, scripts is all of our code itself that we wrote. And you can see here we got in-body planets, solar system, tests, UI, and util classes, and then below that, SimCappy, which is the sponsor's code, with one or two small classes that we added to test connections. And obviously the standard Unity packages are not written by us. Just to show you some code itself, here's a gravity class. This hasn't been integrated. It's in the system, obviously, but we haven't connected it to the front end yet. Basically takes some mass and distances and uses some formulas that we researched and converts that to a XY position that we can use to move the planets around. The ellipse class was an old class that we originally had for part of our physics model, but due to some information from our sponsor, we changed it. So now this class is just going to be used to pull additional information about the planets, like eccentricity of the ellipse and the foci of the sun. And this in-body class here is a class that's going to be used it's a collection class of all the n-bodies in a current system. Solar system model is just a test that it's just a class that we're going to use to test models out. So we'll load in a bunch of default models and insert them into the system with a click of a button, so we don't have to do a lot of extra work when we're testing. Orbital body class, this is going to be the class that's going to connect the back-end code to the front-end code. And this is kind of the important class we've been working on setting up. That way we can actually get this physics integrated into the system and actually set sizes of planets and set masses and simulate the gravity. Body class defines the basic setup of the bodies of a sun, planet, moon, asteroid, that gives it a type, gives it a size and such. The debugger class is the class I showed you from earlier. The console window I showed you from earlier. This is where we're going to be able to enter command line information and actually read that command line information, convert it to functions to give us information based on our system testing. And here's the UI class for that. And then we got our camera controls, which is added this sprint. This was to, because before we just had a flat image, kind of, and we wanted something so the user can actually look around the planets. And so this was added this sprint. So these aren't all of our classes, obviously, but these are some ones I wanted to highlight because they're kind of either the bigger classes or the classes that were just introduced this sprint. Next, I will show you our artifacts for repositories. So this is our GitHub, our Google Drive repository, and you can see it's got everything broken down into different folders, various reasons. Our meetings are all logged there. We got this time card, which comes in a lot of handy. It's for our own benefit. Basically, we log how much time we spend on a task. That way we can kind of judge like how difficult the process is. So for our next sprint, our user story points can be adjusted in accordance with that. We got different guides we've all made. This is a physics guide I made about different things I learned about physics and a lot of helpful links I found. This is a Unity documentation. We all had trouble with Unity from the get-go. So this was some good documentation that Liz made to help us understand how to set up Unity. And now we're diving into our Taiga boards. And in our Taiga boards here, you could see that we have this wiki page called Solar System Designer Body of Knowledge. This is where we got all of our tool chains, our Git integration, and our different rules that we set up for the team for different aspects such as Git, Taiga, and sprints, and some general info that we found useful in additional team roles. And we keep adding to this as the sprints go on. And as you can see too, we have a lot more wiki pages broken down, but those are kind of the ones I wanted to highlight. And this is our task board from the last sprint. I'm just going to go over some quick highlights of some important things. The WebGL build and the gravity model. WebGL is what you just saw, the website. The gravity model I showed you. The scaling we did, but for the use of the demo, we scaled back a little bit so we could show the full size, a better image of the planets. Added the camera functionality. We hosted this on GitHub and added some stuff to the orbital body class and upgraded some of the user interface. And I'll show you our GitHub account. And GitHub account is pretty standard. We all have our branches pretty much organized. The one thing I wanted to show you that was special was GitHub Pages. That's a special branch which allows you to host a web page, and that's actually where our site is being hosted from. And that is our video, and I hope you enjoyed it. Thank you very much.